Thanks for joining us this evening.
Yep, thank you for coming. So I think the first question that we'll look at, just to get some clear context, is what either of us like about oracles. So Ari, what do you like about oracles? What do you think they're useful for? What do you think they're good for?
Yeah, I guess the question is perhaps not so much what I like about oracles as why I consider them to be essential. I think you and I have common vision in this regard. If you cast your mind back to 2018, the peak of the ICO bubble, there was more money going into ICOs than into early stage internet startups through traditional VC channels. This was a seismic event in the world of venture capital, yet there was really nothing technically interesting going on in the sense that smart contracts that manage tokens are fairly straightforward to code and operate in a hermetic world. And yet, this had a profound impact. And the most technically interesting offshoot, I guess, was probably CryptoKitties. And CryptoKitties resulted in the purchase of a digital cat for over $170,000, which led to, as I understand it, Sergey was the fellow who made this purchase, led to interesting cocktail party conversations. But again, nothing technically deep happening. Now imagine if we take that same technology and we connect it to the real world. This is what oracles can do. And most of the visionary applications of smart contracts involve such connectivity. So oracles, as I said, in my view, are essential to make blockchain systems both technically interesting and deep and impactful.
Yeah, I completely agree. I think the reality is that, well, it's not surprising. It's very easy to agree with Ari. He's usually right, so it's just like, you might as well just do it on autopilot most of the time. So I think when I got into this space around smart contracts and around 2014, when we really started building more and more things, the thing that attracted me to this space in general wasn't like the capacity to make a token and move a token around. That was just like a small part of it. And I think in every crop of people that I see coming into this space, every time there's some like economic activity, there's always a subset of people that want to see smart contracts do something useful. And a lot of them come in and they, semantically they look at smart contracts and they think it's smart enough to know what's going on. So they think of it as like data enabled and externally aware automation. And the reality is like different than that expectation. I mean, that's the expectation I had when I got into the space of I can build a smart contract to pay people fairly, or to compensate people correctly for any kind of work, whether the delivery of goods or some kind of digital work like search engine optimization or whatever work you want. And the ability to do that, I think, is something that is just like a natural, logical step forward that I've been working on and hoping for like over 6 years now. So I think that the thing that attracted me initially to this space wasn't even tokens. It was these smart contracts that could do things like move tokens on the basis of an event as a financial product, or create insurance, or right, like these are all the useful things that I imagined. And so oracles, they enable that by connecting one system, the contract system, to the external world, while retaining the security of what people define as a smart contract. And this is, so I think they're like the missing piece of the puzzle, or one of the key missing pieces. And I think tonight we're just going to chat about kind of how is that missing piece evolving, and what are the different parts of it that are getting built out and going to get built out, and what are the useful dimensions of all those parts. So I guess the next logical question is one of the, like, what are the things that you see coming up for oracles in terms of capabilities that you find particularly compelling?
So for most people, the word oracle is synonymous with middleware that does something very specific. It relays data from a website to a smart contract. But I think where things get really interesting is when we think more expansively about the capabilities of oracles. You can think of an Oracle network as an opportunity to build your own permissioned committee. You pay 3 oracles to relay data. You're basically getting your own ad hoc committee consisting of a number of entities you have handpicked and trust. So this committee is quite trustworthy. When you have a trustworthy committee, there's an awful lot you can do beyond merely relaying data. This committee can perform privacy-preserving computation on your behalf, can do secure multi-party computation, for instance, can use trusted hardware, which enables a very strong trust model if you believe in the hardware, can communicate data bidirectionally. There's no reason that a smart contract can't interface with a cyber-physical system and actually control the cyber-physical system. Smart locks, interest in smart locks, which has been around for a while, is an early manifestation of this capability. But in principle, smart contracts can control any system that admits of digital control. Recently, I worked with Sergey and others at Chainlink on a concept called a Mixicle. This is a DeFi instrument, privacy-preserving DeFi instrument. And it's perhaps worth taking a minute or two to explain how it works, because it's conceptually very simple. Suppose that we're interested in creating a binary option. Alice and Bob want to make a bet on the movement of, say, some stock price, XYZ Inc. So what they would like to do in particular is each put $1 into a smart contract, and if the stock price goes up, let's say, at a particular time, Alice earns both dollars. Alice wins $1 from Bob and vice versa. This is very easy to do, of course, if you have an oracle that relays the price of the stock and can indicate its movement. But suppose you want to make this thing privacy preserving. That's really difficult to do on-chain. Blockchains are designed for transparency, not confidentiality. An oracle, though, can help. So suppose that Alice and Bob go to a service provider oracle node, and they say, we don't want anyone on-chain to see what stock ticker we're placing our bet on. So could you please just send a 0-bit to the blockchain if Alice has won and a 1-bit Bob has? And we're going to set up a smart contract that sends money to a pseudonym based on the value of this bit. Well, now you've made a small modification of the smart contract with the aid of the oracle that removes from the visibility of others the basis of this bet that Alice and Bob are making. And you can add other bells and whistles, but that's essentially what the Mixicle is doing. And why do I mention Mixicles? Well, the oracle is doing something here other than just relaying data. It's also helping provide confidentiality. And this, I think, is just the beginning. And Mixicles, in my view, may or may not be exactly the right point in the design space for DeFi instruments. We'll have to see exactly what capabilities, functionality people are interested in. But they point the way toward this more expansive view of oracles and their capabilities and the impact they can have on the ecosystem. How do you think about this, Sergey?
I completely agree with you, Ari. Because I think the reality of this is that blockchains have a lot of interesting properties around security and reliability because they have such a massive degree of redundancy. So they have, some of the more popular ones have thousands of node operators. But it's very difficult to make something like that efficient or to allow certain features when you want dynamic membership and all these other properties that these networks have. So that's why, to a certain degree, many blockchains, at least at this point, that are in production and at a high level of usage, they don't provide things like privacy for smart contract code. And this opens up a large problem and actually a larger question of which privacy is just the beginning. So the way I look at it is you're actually writing a smart contract in two equally important parts. So you're writing a smart contract in the on-chain code that is responsible for transparency, data transfer, receiving payment, holding payment, dispersing payment, interacting with other public keys on that network. But because the capacity, both from a privacy point of view, scalability point of view, whatever other collection of features you want that a blockchain can't give you, Now with an Oracle network that can give you certain guarantees, you can actually make an entire second part of the contract that's computed in that Oracle network. So the first use case for this is, that we've approached is the delivery of data, because it's just the obvious initial use case of, here I am delivering data to a smart contract, because without that delivery, the contract can't exist. Right? It's just like a firm condition for a certain type of financial product to exist. Right? So the logical initial use case for an Oracle network is, let's get data, let's get it to the contract so it can function at all. And there's a lot of demand for that. And as there's more DeFi and more contracts that need to rely on external data, that's just going to continue, right? So we even now have users that are live in production that were able to go live weeks or months earlier because they didn't need to deal with a ton of questions related to oracles, right? Because they had something on chain that gave them that data using something called the price reference data oracle network. Now, if you look at Ari's points and Mixical's, what becomes clear is that privacy is a very clear use case, right? Even if you take a relatively basic contract like a binary option and you split it up into two parts, a portion that's on-chain and off-chain, you suddenly get a whole bunch of privacy properties while still allowing the contract to effectively exist on-chain in a large network like Ethereum or any other network where there's a lot of private key holders that want to put money into it or pay for it somehow. So I think Mixical's is kind of this initial design pattern of here's how you generate privacy using trust-minimized off-chain computation in the form of an Oracle network. But recently we've also released something together with Arbitrum where in addition to some amount of privacy, you also get certain guarantees about a computation happening off-chain. So I think the critical thing here and the way to view oracles and smart contracts working together is you're redefining what a smart contract is to be both the on-chain code and the off-chain code. And the reason that you trust it as a smart contract is because the on-chain code meets certain security and reliability requirements. Now, those same requirements need to get met by the off-chain code. And that's what a process like Arbitrum enables, and systems like Mixical's help provide privacy. So I guess what we're both basically saying from different points of view is that you're seeing a large amount of features that become available even when you do the most basic things off-chain, whether that's computing solidity off-chain using Arbitrum, or whether it's making a binary option in the way that Mixical suggests. You suddenly get two great features: privacy and scalable computation of solidity code, which are both very very expansive in terms of what people will be able to build as a result. So I think what we're really seeing is that data delivery is the first great use case of oracles and oracle networks. The subsequent use cases are about combining that data delivery with privacy-preserving or scalable off-chain computation to augment the functionality that can happen on-chain that can realistically be relatively light because of cost and other data kind of size issues. So I think those two approaches that we discussed are really software-based, so they don't really require additional cryptography or more complex systems like trusted hardware. But there are other approaches that are in the future, in the near future, and they rely on more advanced techniques. And so I think it would be also useful to, and interesting to discuss, some of these approaches. Like what for example, is one of those approaches that you find the most interesting, Ari?
Well, my group has worked on two privacy-preserving, two other things beyond merely preserving privacy. Two privacy-preserving Oracle technologies. One of them, Town Crier, is licensed by Chainlink. What Town Crier does is leverage a technology known as trust execution environment. In particular, Intel SGX. The alternatives are now arising. AMD has one. There's an open source trust execution environment platform called Keystone that will also come to fruition. But what trust execution environments do is enable an application to run in a protected environment known in SGX speak as an enclave. This environment provides integrity in the sense that the execution of the program can't be tampered with, even by the operating system. So in principle, even by the owner of the host in which the application is running. And this should sound familiar. This is a blockchain-like property. It also provides confidentiality, which is very much not a blockchain property, in, again, the sense that the owner of the platform can't see the state of the program, can't observe its execution. And therefore, an application can run with secrets that are not visible to the operating system, not visible to other applications. These two properties together are very powerful, and trusted execution environments are an excellent platform for the deployment of an Oracle node. If you run an Oracle node in an enclave, you get the integrity property. If the software you're running, if the application you're running was correctly coded, this means that you can rely on it faithfully to relay data. And even the operator of the node, if SGX's trust properties hold good, which is to some a big if you believe in trusted hardware, even the operator of the node can't interfere with the execution of the program, and therefore can't tamper with data. But you also get confidentiality. So for example, it's possible for the node to relay data about events that the creator of a smart contract is interested in without even the Oracle node operator knowing exactly what these events are. I gave the Mixical example. You can, using Town Crier, although if you're using trusted hardware, you may not need Mixicals, but just for the sake of example, using Town Crier, you could implement a Mixical in which not only is XYZ Inc., the basis of this bet that Alice and Bob are making, not visible on-chain, but it's not even known to the Oracle node operator. It's concealed from the operator. The Town Crier project was led by my student Fan Zhang, by the way, who's just about to graduate. And he has more recently led a second project in my group, a new Oracle technology called DECO, Decentralized Oracle. We realized in retrospect that DECO is a somewhat misleading name, because DECO is not really a decentralized Oracle in the sense of decentralized Oracle network. It's a technology that supports decentralized Oracle networks. DECO does a subset of what Town Crier can do. In particular, it allows for privacy-preserving Oracle operations. But it doesn't rely on trusted hardware. It uses cryptography alone. And consequently, the workflow is a little different than many of the Town Crier use cases we've thought about. In particular, DECO involves the user providing data to the Oracle node in a confidentiality-preserving way. And so I'll give you an example. Suppose a user wants to generate a credential, proof on-chain, that she's over 18, and therefore legal age to engage in a contract. What she can do is log into a website with a trustworthy record of her birth date, say the State Department website. Log into this site, and if she logs in a cryptographic protocol jointly with the Oracle node, what she's able to do is prove to the Oracle node that the birth date recorded by the State Department is such that she's over 18. She can prove this to the Oracle node. She can prove she's over 18 without actually revealing her birth date to the Oracle node. And the way she does this, in a nutshell, is by sending the Oracle node a zero-knowledge proof on the transcript of her conversation with the State Department. This has to be done over TLS. Right? So she needs to communicate with the State Department over an encrypted, secure channel. Once she's done that, she can create a zero-knowledge proof on the transcript that shows that she's over 18. So the Oracle node learns that she's over 18 and now can produce this credential, this attestation saying, yes, I believe Alice is over 18. She proved it to me by talking to the State Department website, and her birth date supports her age claim. I performed age verification. And you can use Deco for lots of different purposes. This is just one example. You can use it to create privacy-preserving mixtables, for instance, in which the basis, the bet, again, is hidden. Those are two of the Oracle-related projects my group has worked on in relation to the confidentiality problem in particular, right? And those both represent forms of off-chain computation, of course.
Yeah, it's fascinating stuff that I completely agree with. It makes a ton of sense, and I think there's just so much going on in all of these that there's just a useful distinction. The way I understand these systems is that Deco basically requires user participation for somebody to provide the data that then gets validated.
Right. Yeah, I think that's a good way to describe it.
Using this cryptographic scheme, which doesn't require trusted execution environments. So it definitely has that benefit, but it requires the user to engage in giving the data by essentially initiating the TLS session in order for things to be validated. As I understand it, town crier, that can basically do the same thing if you're able to rely on trusted hardware and that trust model in addition to decentralization, and it can also run kind of separately without user participation. It can get pieces of data programmatically without a user sending it anything.
Right, so town crier can do everything Deco can do and more, but it relies on trusted hardware. And there's some who don't trust trusted hardware in view of recent speculative execution attacks and so on and so forth. To some extent with good reason, although I think the technology will become more and more robust, and that for many purposes it's adequate today, particularly if deployed with defense in depth. But yes, Deco does a subset of what town crier does and requires user involvement for most of the use cases we consider.
Yeah, I think just as a tangent, I think the whole trusted execution environment thing is quite interesting, because I think people see some kind of mutual exclusivity between decentralized systems and trusted execution environments, where, as you said, in my experience, defense in depth basically dictates that if you can get additional benefits from layering trusted execution environments on top of decentralized systems, and the technology holds up because it's been attacked enough and it's been hardened enough, that it seems like a very logical point of view in terms of adding additional security.
Right, it can add additional security, and another way to view blockchains and trusted hardware is as complementary technologies. Blockchains provide persistence, robustness. You put data on a blockchain, you know it will stick there, you know the blockchain will run persistently for, in the case of Bitcoin, well over a decade, which is quite impressive. But blockchains are inefficient when it comes to smart contract execution. Smart contract execution is costly. Transactions in general are costly. And it provides transparency, not confidentiality. Trusted execution environments, in contrast, don't offer persistence. You can just shut down the node in which a trusted execution environment is running and you lose all state. But they provide confidentiality, which blockchains don't. And they are also much more performant than blockchains. You get, in some cases, close to native execution speed for applications running in trusted execution environments. There's some overhead. It depends on the workload, but in general, they provide much better performance than you get on-chain. Putting the two together is an interesting and I think very valuable proposition.
Completely agree. I'm not kidding. It makes perfect sense to me. I think I see more and more useful approaches for various different forms of off-chain computation, whether it's for confidentiality or scalable off-chain computation that provides certain cryptographic guarantees. And I kind of just see the capabilities that developers have to build all of these things expanding, right? So data delivery, the capacity to do computations privately that are still trust minimized, that can use blockchains for persistence and data transfer and maybe getting money from different private keys, and that then can go on and also reach high levels of scalability. I think all of this is literally kind of happening right about now. So last year, this year, you're seeing people finally get high quality data from something like price reference data networks. You're seeing people getting privacy-preserving computational capabilities off-chain that are still reliable enough to be considered part of a contract, and also some scalability-generating approaches from great groups like Ari's. And I think this really creates an environment where next-generation smart contracts can get built. So we were trying something new where we're taking questions from our community, because we're doing our best to find ways to interact more and make sure that we're kind of looking at the things that they find interesting as well. One of the questions that came up on Reddit from somebody called CryptoQuid, because it's with a Q, of course. In any case, the question is along the lines of, there's all these applications that people come up with as web developers that we couldn't really foresee, like Uber and all these other systems. In 5 or 10 years, what are the cool applications that we see coming into existence, and really kind of realizing the full potential of, if all these systems broke and existed in 5 or 10 years, what would we be excited to see come into existence?
Well, the first paper I wrote on smart contracts was about the use of smart contracts for crime, like assassination contracts. Assassination is a little over the top, as an example, but criminal uses of smart contracts are something, unfortunately, that I think may well come about in the next 5 to 10 years. And to some extent, we've already seen criminal smart contracts that are exploiting existing systems, as in the
Are the things you're excited to see?
BZX. I would certainly be excited to see it.
Things you want to see and
things I want to see.
Things we won't be involved in.
That's a different category.
I'm sorry, Ari's a very smart guy, you have to be very specific. Things you want to see and which we will not be involved in.
Right.
Sorry, things you want to see and which we will be involved in, but not things you're excited to see and which we don't. You're not going to be working on.
I think I got it.
You got it, thank you.
Okay. Well, I did mention criminal smart contracts because I think there's something we need to think about as a community. But okay, let me get off that topic. Obviously, Sergey, you can see Sergey squirming here. I'll mention a project that my group is working on at the moment, one I've just started with a first-year PhD student named Sishan Wong, whom I'm co-advising with Carla Gomez, a faculty member at Cornell, whose group focuses on sustainable computing. We're building a system which, for the moment, we've dubbed AIRS, Automated Incentives for Reforestation, stewardship, whose goal is to create a smart contract that does the following. The contract references an oracle that ingests satellite data and monitors the conservation of forests. In particular, measures their carbon capture capacity, their ability to sequester carbon, how good a carbon sink they are. And when a forest has been well conserved and ideally expanded, pays money to local residents, those presumably who are responsible for the good stewardship of that tract of forest. So the idea is you pour money into the smart contract and it gets dispensed, sent to people who are responsible for maintaining and expanding this very important carbon sink. We've just begun this project. It's obviously an Oracle-based project. I imagine it will take at least a few years to come to fruition. I think it's much better than a criminal smart contract.
Much better.
I think it is an example of the type of thing that smart contracts can in principle do that can, I hope, make a big difference. This is a social good project, of course.
Yeah, I think it sounds great. I think there's all kinds of things where you could incentivize people with tokens. I'm assuming there'd be some kind of incentive with on-chain payments, probably.
With cryptocurrency, we could actually build an Oracle connection to an existing digital money system like M-Pesa in Kenya, as an example.
And so people would be guaranteed that if they extended a certain amount of effort towards conservation of certain forests or other natural resources, that would be seen reliably, and they would get paid.
Right, exactly.
And so you would form kind of a technical contract with them rather than a legal one, and the technical contract would actually be, in their mind, game theoretically more reliable. So they would engage in the behavior because they would be guaranteed that their behavior would result in the incentive.
We hope that we're incentivizing good behavior, right, when it comes to the stewardship of forests, exactly.
Yeah. I mean, it's a fascinating thing. All the things that people can come up with if you can get contracts to work in a technical manner that utilizes all the digital proof that exists about what's going on.
Right. This is a technically much more advanced example than we currently have deployed in Ethereum, to the best of my knowledge. We would need to do analytics on satellite data in a trustworthy environment and so on and so forth. Right? So it would require some heavy lifting. But as I said, this is an example of the type of thing that I would at least like to see in the next 5 or 10 years.
Yeah, it sounds fascinating. For my part, I see a lot of use cases, not exactly like this conservation idea I think is pretty unique and shows just how far a well-functioning digital contract can go to help society, right? Even separately from all the efficiencies it creates for developed or emerging markets. I mean, the types of contracts I see in something context like this would be the capacity to provide rainfall insurance to emerging markets where they don't have insurance against rainfall. And because the local legal system doesn't allow insurance companies to function properly, basically. But people don't really think about rainfall insurance, partly because they don't farm and partly because the people that do farm take it for granted. But in a lot of parts of the world, because the legal system doesn't work properly, you can't have a certain type of contract, essentially with society, if you consider insurance companies like, of the way society manages risk. Society can't give you an ability to manage risk. And the consequences of that are extremely large. And people that have that ability to manage risk, they don't think about those consequences, because really a lot of the financial contracts that people use for speculation, and there are many variants, they originated from people's desire to insure themselves against negative events so they could engage in economic activity, right? So you can have a farm for multiple years through good rainfall and bad rainfall because you have an agreement for insurance that will make you whole in the bad years and allow you to continue to the good years. And that was the basis of futures contracts, a whole bunch of different agreements, which would then turn into speculative instruments. Likewise, insuring ships to travel across oceans to discover things, right? That's what allowed people to take the risk on that economic activity to travel across oceans and discover things. So every time, I mean, in my view of all this in 5 or 10 years, every time historically that a society has improved how its contracts work, usually through the improvement of its legal system, that society has enabled all kinds of economic activity that goes on to redefine it, right? That's all kinds of law, labor law, IP law, contract law. All of this creates an environment in which economic activity takes place. Ventures like this reforestation project can come into existence that in a way that they couldn't before. So I mean, what I see in 5 or 10 years, once we've given people that want to build these contracts all of these different tools, is a capacity to very quickly basically eat up or kind of take over all of the digital agreements out there. Basically every digital agreement that you would want to make, if it becomes easy enough and cost efficient enough to do, could be backed by smart contract guarantees. Now the two very significant things that I see coming from this, one is in developed markets, you would have financial systems work in a way that systemic financial risk is not such a large problem. Because the fundamental issue in developed markets is that the opaqueness of how the global financial system works means that certain people can benefit to a very large degree while feeding huge booms that then result in huge busts, which then the rest of society pays for. And those booms basically happen because there's an information asymmetry. Because the people who exploit the inefficiency in the market feed the boom, like in the 2008 crisis, where a few people saw an inefficiency, they exploited it, and the reality is the inefficiency shouldn't have existed, even with the level of IT technology then. But systems like blockchains and smart contracts would force developed markets to work in a way where, even in the example of the 2008 crisis, each individual mortgage holder could have a smart contract about them that then is appended with new data and moves between institutions, right? So it goes from the local community bank that issues the mortgage, to the commercial bank, to the investment bank, to the holder, to the final holder of the basket of securities. And that would allow people to research back all the way to what composes this basket of these million separate contracts and assets. And the only people that were able to do that was a very small subset of people, which is why that boom essentially happened, and affected society in a very large way. So in developed markets, better contracts basically allow markets and systems to work in the way that they're promised to work, rather than the way that people want to exploit them to their benefit and to the detriment of larger society. And in emerging markets, I feel that in 5 or 10 years, we'll see a similar leapfrogging to what we've seen with the telecom industry and then the internet, right? So there was a huge leapfrog effect where the feature phone was inaccessible, and then cell towers and the infrastructure to set up a local telecom system dropped in price massively. All of a sudden, people had telephones. They didn't even have landlines before this. Right. Then those telephones turned into $50 smartphones, and now they have the internet, right? Now they have Wikipedia. People went from no information, or pretty much almost no information, to the quality of information that I have with the capacity to access information. They have the same capacity. And I think that a technically enforced system of contracts that works in all these different use cases, is going to, once again, allow people to leapfrog past essentially a broken legal system that in many emerging markets just doesn't allow people to lead a fair, dignified life. They don't have access to a way to save money, a way to transfer money to people, a way to combat inflation and maintain the value of the money that they spent their life earning. And it's not something that I think a lot of people in the developed world immediately relate to, but I think if you think about it, that is really a world-changing series of events, that people in these markets could suddenly have all the capabilities we do in terms of managing risk, fighting inflation, saving, making an economic future, regardless of if their local government can help them do that. What do you think, Ari?
Well, it seems that insurance smart contracts are actually not that far off. In fact, Chainlink recently formed a partnership with Etherisk, is it?
Yeah.
Life insurance.
Yeah, it's not far off. They have rainfall. I think they have a hurricane catastrophic risk product that's coming. I think they do have another weather product. And I see actually more different insurance teams seeking to make insurance products for both retail and developed markets and emerging markets. So I think really I'm starting to see finally, after year of this is the year, here we go, this is the year. It's constant, my constant story. You ask anybody that knows me, this is the one. Finally, this is the one. You're starting to see kind of people going to production with DeFi products. That's past $1 billion. People in any place with the internet can use that to combat inflation, to hold value. You can start seeing some insurance products starting to go live. So, I mean, even if it takes 5 or 10 years, I think it's absolutely worth it, in my opinion.
I think that's encouraging. It's emergence of so-called parametric insurance, I think, early substantial impact.
Great. So feel free to come next year to hear about how that's the year too. We'll welcome you with open arms until it actually happens. But this is the year, just to be clear. Okay, so it's been great chatting with you, Art. Thank you so much.
Thank you.
Thank you so much for joining us and sharing your group's work and your very thoughtful point of view on oracles. I think it's been a great conversation, and I really appreciate that we have the chance to work with somebody like you. So thank you.
It's a pleasure working with you, Sergey.
Thank you.